Okay. Welcome to Object-Oriented Programming. Maybe we can have a short sound check in the beginning, so I hope everyone hears me, although we don't have a second headset microphone today, so we have to deal with that situation. And what about you, Julia?
Okay, hello. Yeah, so for some reason the second headset just went missing.
But nevertheless, let's continue, and maybe we have a short look what we're going to do today. Maybe you can introduce the bullet points of today.
Yes, so we'll start by finishing the recipe class we started last time, and then we'll quickly talk about copy constructors, destructors, and dynamic memory, which you heard last time in the lecture. Then we'll get a bit more in depth and talk about shallow copy versus deep copy. And then we'll show an example of an UML diagram, some organizational methods, and if we still have time, we'll look at the map data type.
And otherwise, we'll do it next week.
Yes.
Okay, then we start with the classes. And of course, I think that everyone has worked with classes in assignment 1, and I hope it's very familiar for you. Nevertheless, I will just go through it very quickly. So in C++, we write class and then we declare the class name. We have member variables, which would be the string and the vector in our case. They are usually private because we don't want them to be accessed from outside of the class. And then we have also a public section in each class where we have different methods. So they implement some functionality of the class. And we also have scene constructors that create such a class object and initialize the members with it. And this is already this recipe class that we implemented last time. And maybe just a short recap what we did last time, because we will continue from there. So we created a class for recipes, and each recipe has a name and a list of ingredients. And the ingredients itself are also classes where we then have a name of the ingredient and the amount and so on. And these ingredients are stored in the recipe. And we started implementing already something, and we will continue from there. Maybe you can continue what we have seen last time.
Yes, okay. So let's start with the main, just to get an overview. We created this ingredient class, where you can see, okay, we have this name here, then we have the amount and also a unit which this ingredient has. We wrote some print method for this ingredient, and then we created the recipe, which also has a name, and then we have this set ingredient class, which maybe we'll just take a look at this. This setter did something special because it already checked if there's an ingredient with exactly that name in this recipe, and if it is, then we just replace that ingredient with the ingredient we want to add. So here in the main we use this because we added too much sugar here. We set a new ingredient, called it sugar, and then just overrode what we have. Do we have a make file? Yes. Okay, and as we can see, this works. We just have 5 grams of sugar instead of these 100 grams we wrote up here.
Maybe you can also show us the recipe class, so that we just have a look on the recipe.hpp. But we have already seen that before, but nevertheless, you have the string, the name, and this vector of ingredients, and each ingredient has then the name, an amount, and the unit. So is everyone familiar with these classes that we implemented last time? I think so. So let's continue with the new functionalities then.
Okay. So we have a new to-do, and we want to construct a new recipe out of the recipe we already have. So this salad with, let's say, for more people. So we want to scale this by some factor, and we want to implement a method for that. Okay, let's go into the recipe and create a new method for that. I'll just call this adjust recipe, and oops.
Yeah, you can switch the keyboard layout, yeah. And I was cheating before with Copilot, okay, yeah.
Okay, so, but we don't want to adjust this recipe, we want to create a new one with the scaled values. And this is something I wanted to show you, namely that you can return a class from in with itself. So you can create an instance of recipe within another instance. Maybe this sounded a bit confusing, but I'll just show you. So in recipe.cpp, we can do something like this. And what we want to do now is return a new recipe with this scaled ingredients. And to do that, I'll create this new, let's call it scaled recipe. And yes, I think, did we assign it to the current?
Yeah, we
just passed.
We had a constructor which took the name of the recipe.
Yes, our constructor just takes the name. Okay, and then we want to iterate over all ingredients, adjust them based on the factor, and add them to the new recipe. So like this. And now we want to somehow, from this ingredient, change or create a new ingredient with the adjusted value. And because we don't have a setter or anything, and we don't want to set it, we just want to get a new ingredient with this scaled factor, I'll also create an adjust ingredient method in the ingredient class. So we'll just pass the factor down there. Oops. And then in here, we'll just return a new ingredient. And the constructor took the name, then the amount. And now we want to scale it with the factor and the unit. And when we pass this here to the constructor of the ingredient, everything is automatically copied. So we will create a new one.
So why can we access now name, amount, and unit directly in this method? And to which ingredient object does these belong?
Yes, so this name here belongs to the ingredient we are currently in. So the ingredient we are calling adjust ingredient on, and we are just passing it to the constructor of this ingredient.
Okay, so we have
a new one.
An ingredient in an ingredient, more or less.
Yes.
Okay.
Okay, and now we can call. We need to call this. We need to get the scaled recipe, then set an ingredient, and this new ingredient should be the one from the current recipe, adjusted by the factor. So this here returns a new ingredient which will add to the vector of the new recipe. And then we can return the scaled recipe. Okay. Yes?
Is this all saved
Okay, so here, when we create a local variable like that, it's on the stack. So local variables, if you do not do anything with new or use any class which maybe internally calls new, then it's on the stack.
So if we return ingredients, the copy constructor makes a new one here, and it's on the stack now. Right?
Yes, you can think of it like that, but the compiler may optimize this away.
Okay.
Yes?
I'm sorry, I'm a little bit confused. Do we make a new ingredient with the scaled amount of old ingredient, or do
Yes.
we scale the amount?
But maybe you can always repeat the question. We always forget that.
Oh, yeah. So are we creating a new ingredient, or do we scale the amount of the ingredient we have here? That's the question, right? Here we are calling the constructor of ingredient. Within it, a just ingredient. So this method actually returns a new one with the same name, the amount scaled by the factor, and the same unit.
Maybe you can open the recipe.cpp next to the ingredient CPP on the other side. Yeah. So here on the right-hand side, we are calling ingredient.adjust ingredient.
Here. Oops.
Yeah. So then we go to the left side, and we are in a method of an ingredient, and this always refers to an object, and this object is the ingredient from the right-hand side, where we called the function with this dot. And then we have this constructor, as Julia said before, and this constructor creates a new ingredient. And this is what we then return from the function. So one ingredient returns another ingredient in that case. And there are two different objects.
And because it's on the stack, we can also return it just like that.
One more question.
I have a question. If I were to define a function in the recipe.cpp, which inputs another recipe, I can also even if a member is private, I can still access it directly. Is this good practice, or should we always use the getter?
Okay, so the question was, if we get an object of, for example, recipe, passed to a method of recipe, but these two are two different objects.
Yeah, is it good practice
Yeah.
to use the getter, or doesn't
Okay. Okay. And then, is it good practice to directly access the private members of this other object, or use the getters? Personally, if you have getters, you can. I would maybe always use them, but if you can, of course, access the private members if this is necessary. But I would always use the getters if they exist.
So in our example, for example, the set ingredient method of the recipe, there is some more logic, so it makes more sense to use it than just do it directly. Maybe we can show this also, that you access a private member in the scaled recipe in this method here.
Yes, so here with scaled recipe, for example, we could access the name private member, and this would still work.
But the important thing here is the scaled recipe is not the object where the method is called on. This is another object, but still, as we're in the scope of the class, we can access of the other object the private members directly.
Yeah, so these two are different. I mean, they have the same content, but these two are different objects. This name is from the scaled recipe, and this one is from the current recipe where you're calling this method on.
This is more or less a takeaway from this example here.
Yeah. So maybe just let's call this method from the main and check if this works. So let's call it scaled salad, and then adjust recipe and maybe 10 dimes or something. And yeah, we have a print function. And then let's try it and see if it works. Yes, and we can see here first, we have the normal salad. with 5 grams of sugar. And then down here, we have the one we have adjusted up here. And this now has 10 times the amount of sugar.
No, just the salad is missing now. Okay. Are there any questions regarding that topic before we continue with the next part here? Okay, it seems to be good. Otherwise, just ask later. We have a second to do for today. Last time in the lecture, we have seen static variables, and we want to implement now a counter that counts how many recipes are currently created. So in our example here, if we create here this salad recipe, then the counter should be 1. If we continue to the scaled salad, then the counter should be 2. And then both recipes are destructed after the main finishes. So after the main has finished, the counter should be 0 again. And now I try to implement it, and you talk to the people here.
Okay, so I think first we'll create a static variable in the recipe where we want to store the amount of recipes that have been created. And yes, as you remember from the last lecture, we are using these static variables because they only exist once per class and not once per object like all other variables.
And unfortunately, static variables cannot be initialized here direct in the recipe. So I have to initialize it now in the CPP file. So we'll do this now.
Yeah, and to initialize them, it's quite similar as with methods. You have to write the class name, then colon, then the recipe count, which is the static variable we created, and then set it to 0. And you don't need the static. So it's just like this, and it should hopefully compile now. Yeah.
Okay. And then next thing that we need to do is whenever there's a recipe created, we need to increase that count. And we already have a constructor, and we will use this now. And we have this recipe constructor here. So now it's the first time that we're really using the body. And we set here now our recipe count plus plus. So we increase it by 1. And now there is a new thing coming up. So whenever an object is destructed, we also want to decrease the count. So it's the first time in the practicals that we implement the destructor, similar syntax as the constructor, but with this tilde symbol in front. It does not take any arguments because for what reason should we take arguments here? And we decrease the count in this case. So this should already work, and let's try it out in the main. So maybe I can write some standard cout here.
Cout. Okay, so we want to access this static variable in the main now.
But it's not working. Why does it not work? Of course, we have it private. So also for static variables, these access specifiers are important. So we need to write now a getter for the recipe.
Yeah, and ideally, we'll also create this getter. We'll create a static getter because if we want to access this count without having any recipe, we would just want to access it on the class. And now, maybe you need to include IO stream.
Yeah, I need to include IO stream. We have this here. And no auto-completion today for me. Okay. And probably it should work now. No.
You didn't call the static method.
Oh, I have still the constructor here, so I need to call the getRecipeCount method. And then we can compile it and run it. And okay, we see here now this new output, which is 2. And this is, what we expected because we have the salad here, and then we have the scaled salad. So the recipe count should be 2. And maybe we can implement here something. We just write some if here that is always true, and create this scaled recipe only in the if, because then we expect, of course, if we leave this block here, that the recipe count should be decreased by 1, because after the block the scaled salad is removed. So let's see. And let's try it now. And now we have only 1 recipe left, because this scaled salad is destructed after the block of the if. Okay, that are our static variables. One more extension we can do, and this is what we do in the ingredient.hpp. We can combine static and const, and we can create a const static variable.
Yeah, this is very useful if you just have some constant, and this constant only makes sense within a certain class. So this is a way for us to group our constants together, so we don't all have them globally available everywhere.
And of course, we have to initialize them. Static is not needed here, and I want to create a bullet point, and you will immediately see what I mean with that. When we list the ingredients of a recipe, then we wrote the star here, and now want to change it to another symbol and create this string. And this should not refer to a specific class or a specific object, only to the class itself. That's why we do it constant static. And now we can use the bullet point here. And since we are in a method of the ingredient, we can use bullet point without referencing to the class. Because we're already in the scope of the class. If you compare it to the main function, where I use this static function or static method, I needed to write recipe because we need to refer to the class, and here we're inside of the class, so we don't need to do that. And if we try it one more time, then I have not written here the ingredient. Of course, here we are not inside of the class, because only in the method we are inside of the class, here not, so we need to write ingredient here. And now let's try it one more time, and now this also works. And you can see we have here the minus symbol instead of the star now. Yeah?
I'm sorry, why again the scale salad deletes in the end of the if?
The scaled salad deletes because it only lives in the scope, starting from this bracket to this bracket.
Yeah. You couldn't access it outside here. So this wouldn't work because it doesn't exist here. And that's why it's already destructed. I think you'll hear more about that in the lecture today, about scoping.
I think scoping was last time in the lecture,
okay.
So you should already know that. Any further questions regarding our 2 classes here? Or should we move on to the next part?
Okay.
Okay, then move on, I think. Oh, now I think it gets a bit funny.
Yes.
Okay, maybe we reload.
Because last time Menti didn't work, we're trying Slido now, which was already used in the lecture.
Yeah, it works.
Yeah, and hopefully the quiz works.
So just log in, and I think there are not more than 100 people here because only 100 can participate.
Yeah.
It shouldn't be a problem. Now, when you start, then it works on my PC. Okay.
I think it should.
But there is no timer, right? So it's no problem.
No, there's no timer.
Yeah, maybe you can start with the first.
Can I somewhere see how many joined? I think in here, no.
Just go to the first question.
Yeah, okay.
There is no time limit, right?
No. So let's start with the first question.
Oh, yeah. I hope it's large enough.
You don't see it on the screen, but I think on your phone you should have description with the code.
But there is something missing, right?
What?
What are A and B?
Yeah, it's in the description.
It's in the description there. Okay.
Do we have
do you see the definition of A and B? Yes, okay.
Okay. Yeah.
With 11 answers, 13 answers.
17. Okay, yeah, I think this works. Can you see on your phones how many answered the question? Which chose which answer? Okay.
Okay, then
Oh, it's
maybe we
pretty-
go to the
Yeah, okay, so
answers. So 50 is, I think, a good number.
I think I can show the result now on the slide. So it's pretty even split. And maybe now let's look at the answer. And yes, the second one was the correct one. And
I can open your code, right?
yeah, I think so.
You have it here.
Yeah, just do it like that.
Yeah. So why is that the case?
Okay, so this was the code. And here we wrote the const in this position. This means that it affects the integer, so the data type, but not the pointer. And therefore, we can't set dereferenced A to 9 because here we would set the contents of this variable of B, which we can't because we said it's const. And here we would set the address which A points to, but we can't do this because only the contents is const and not the pointer. So we can write const here, and now also the pointer would be const, and the second one also wouldn't work. Yes?
Which one is now the correct answer?
Okay, the correct answer is the second one. I think, yeah.
Oh, they flipped their order.
Okay,
Yeah. Okay.
I guess you can change which answer you. Oh, I can lock them here. I should have done that before.
Yeah, we were still learning.
Yeah. Okay, then let's continue with the next
Yeah.
one.
Next question.
So this one is a bit more complicated. Maybe
Yeah, you can open the code already.
we have this code here.
So there are many consts and
Yeah.
many pointers.
And remember, this is a multiple choice, so maybe you can select more than one.
Maybe this is also a trap.
Yeah.
Two answers already.
Yeah. I can also switch back.
Have you locked the answers at
No.
this question? Maybe you can.
No,
locking.
afterwards, yeah.
This is the locking. Okay.
Okay, we had 67 votes in the first one, so maybe just wait a bit.
I think until we have 50 persons, I think then we can show the answer. Okay.
So I will now first lock it and then show the answer. Okay, there's some more.
It's okay.
Okay, I'll lock it. Okay, now show the results. And now the correct answer. Yeah, so it's only one. And it's this one.
And it's the answer with 2 stars. Why is the answer with 2 stars the correct one?
Well, let's go through it step by step. This const affects this pointer. So it's more like this. This const affects this pointer. So, yeah. And this const affects the integer. Therefore, if you dereference, or if you don't dereference it, it would assign this pointer more or less, but it's constant, so this doesn't work. If we dereference it once, we get to this level here, which is also constant, so this doesn't work. If we dereference it twice, we get to this pointer here, which is not const. So this one we can assign, therefore B works. And if we dereference it 3 times, then we are accessing the integer directly, and this assignment would compile.
Okay, so double star is the answer.
Yes? I don't think so. So the question was if such a coding construct would be in a real-life example. A triple pointer maybe, but with alternating constant flags, I don't think so.
No.
Maybe not.
But at our exams. No, that's
no.
not true.
Not at the exam.
And the third question we have, and I think we don't have that many stars at this question.
Yeah. So maybe just notice that here we have 2, first we are creating this class and then here we are assigning. So these are 2 statements.
And remember, it's a multiple choice question.
Yeah.
Okay, then make yourself ready for locking the question. Yeah.
Perfect. Okay. So let's see the results. Okay, so most of you thought that this last one down here doesn't call the copy constructor, and you're correct. Should I reveal the correct solution?
Reveal them right away.
Yeah, these 2 are correct. The first one calls a copy constructor. This was presented in last lectures. If we create my class B and then directly assign another object to it, the copy constructor is called. The line below that is more or less the same thing. So we are calling the copy constructor even twice in this example. So first here, and then we are also calling the copy constructor for D. Then down here, we are not calling the copy constructor because just assigning to some object doesn't call the copy constructor, but something else. I think you'll learn later.
2 weeks, I think, in the lecture.
Yeah. But just an assignment doesn't call the copy constructor.
Yeah, and the last one trivially doesn't call the copy constructor.
And the last one just calls the constructor.
Okay.
Yeah.
Is there anything like a leaderboard?
I think so.
But not here.
Yeah, maybe we can try. If we go to present here. Then I think I saw it somewhere. No,
No, I don't see it here right now. Unfortunately, no leaderboard
or maybe
for
I
you.
have to close the poll.
Doesn't matter.
Okay, yeah.
Everyone is a leader who participated in our quiz. Okay, then continue with the lecture material. Destructor, we already implemented it before, just a very short recap of it. So whenever an object is destroyed, the destructor is called, and usually you use it then for freeing memory. So when you have some resources allocated dynamically on the heap, and when your object is destructed, then also those memory should be released. And already the syntax we have seen before, we're just writing the tilde in front of the class name, and this is then a destructor of the class. Then what we have discussed in the quiz was the copy constructor. So it creates a new object from an existing object, and the important thing is that really a new object must be created. If the object already exists and we're just assigning something else to it, then a copy constructor is not invoked. Generally, there is always a default copy constructor created by C++. So if you do not implement a copy constructor, then there exists a copy constructor. And this is very simple because it just takes all members that are in the class and copies the values of the members in the object that is newly created. And if you want to implement some further functionality, then you have to write the copy constructor on your own. And the syntax is always like this. It's a constructor, so we have just a class name and no return value. And what do you pass to the constructor? An object of the same type. And usually you want to pass, no, not usually, you have to pass a reference here. So you are required to use the reference here. Otherwise, you would need the copy constructor such that this A is copied to the function. But you are implementing the copy constructor, so it wouldn't make too much sense. So you really need the reference here. And usually a copy constructor has no side effect on that object, so I write const in the front here, because you do not want to change the object that you're copying. And then last time we also saw a dynamic memory.
Yeah. So if we just use new here with some type, we'll just create one element. So this we create an integer pointer here, which is one element. If we want to create multiple elements on the heap, we can use these squared brackets. And yeah, this is like a stack array then. So you just write these here, then, and if we write here 5, we're creating an array on the heap which has 5 elements. For freeing them, for single elements on the heap, this is very easy. You just call delete. But if you have an array on the heap, you don't need to specify the size. You just need to specify with these brackets here that you want to delete this array on the heap. Yes?
It's so to check if an address which is stored in the heap, if it's still allocated, or is it not possible?
No, so technically maybe, but there's not really a way to do that. It also wouldn't make much sense because maybe the memory is reused for something else, then you wouldn't know if it is still the same object there. Mm-hmm.
Do you have to assign the size of the array in the code, or so? For example, if now I'm making a new variable, let's say C, and I say new integer C, and I ask the user to input this C to make the size of array equal to C, it won't work.
So the question is if this 5 has to be constant or if this can be any variable. Yeah, so this can be any variable. You can create arrays of dynamic length with this new.
Okay.
Mm-hmm.
There was one more question up there.
The what? So is there a reason why you use an array and not a vector? No, not really. Normally you would use a vector, but maybe for some special things you want to use an array. But normally just use a vector.
Yeah. But if we want to demonstrate how it works, we need to use the array, of course. And one more question here.
Is there a way to more easier deallocate a vector of new pointers, or should we use for loop for vector?
The question is there an easier way to allocate a vector of pointers which point to the heap? So the pointers we create with new?
Yeah, there is a way to dynamically deallocate array with these square brackets. Is there a way for vector?
You don't need, so the question is there a way to deallocate a vector like this here? Yeah, so, you don't need to delete a vector because the vector already has a destructor which cleans up the vector.
I guess the question was because, for example, in the assignment 1, we had vector with the vectors filled with pointers to some dynamic memory, and we, for example, I made the allocation of memory with a for loop, and the question was if there were an easier way to do this without the for loop.
Thank you.
Yeah, okay, so the question was if we have an array or a vector with pointers that point to the heap, or if we create it with new, is there a way to automatically free all of them? And I don't think so. You would need to loop over them and free each element.
Yeah, I would say the same. Okay. Yeah, one more thing here. Dynamic memory.
Yeah, we don't know how to handle out of memory yet. And when will we learn this?
Next week in the lecture.
Yeah.
Okay, then we come to our second example. And yeah, maybe you can clean this up a bit. And in the time in between, I will just explain what we're going to do. We implement an array ourselves to demonstrate this dynamic memory. And it will not be that easy at the very end because we will encounter some special cases that we need to consider. Now you can open the slides again. I think I have a slide about that. Yeah. So, no, we don't have a slide about it. I'm sorry. Okay, so this is our plan. We just create an array on the heap, and it should take a length, and this length should be allocated on the heap, and then it stays the same length during the program, but the important thing is just on the heap. Maybe I can ask you that you program, because it's a bit hard talking and programming. Okay, so what do we need? And this array, we call it now list, and we need, of course, some length information. So we always need to store the length, and we, of course, need to store a pointer to the heap. And we call this array, and then we can already write the constructor, and our constructor just takes the length of the array, and yeah, the length will be assigned to the length, and we allocate array on the heap, as we've seen before, with the specific length.
Should I do it in the body?
Yeah, do it in the body first. So we have array, and then this syntax that we've seen before with new integer array.
And we want to have wanted to have the length of length. Okay.
And now we've implemented in the body because maybe it seemed to be a bit more difficult than it really is, and we see even if we don't assign a parameter of the constructor directly to a member, also this new integer length is not more than a simple assignment, so we can also write this here in the initializer list instead of the body. Okay, so now we have created a constructor, we allocate the memory on the heap, and now we have our array available.
Yeah, do we want to call it?
Yeah, maybe create it. create such a list of, I don't know, size 10 maybe, and
Yeah, we can't do anything with it yet.
maybe you can change that. You can close that on the left side, I think, at the menu,
Oh,
and we have more space available.
okay. So I want to replicate the add method of a vector. So I want to access our list at the specific index and get back a reference which I can also modify. So we'll return a reference to an integer, which is the integer on the heap. Call this the add method. Take the index and yeah, maybe I'll implement it in the body. Oops. Okay. So what this add method also does, like with the vector, is check if our index is within bounds. So I'll do that too. I want index to be greater or equal to 0, and I want index to be smaller than the length of our vector, like this. And if this is the case, I think I call it array, want to return the element in the array at this index. And because we're returning a reference, I don't need to dereference anything or something like that. This just works. But now, what do we do if this is not within bounds? Yeah, maybe we could print something.
And what else do we do then?
What?
Yeah, it should be fine.
Okay, yeah.
What else should we do then?
Yeah.
Can we do something?
We need to return integer reference, but we can't because we somehow have an error case, but we don't have any return value which you can use to specify that this is an error. So we can't do anything right now. Yeah, but you will learn what you could do in this case again
next week.
Next week.
Same thing as if the dynamic memory doesn't work. So
Yeah.
we don't know how to do this right now, but the important thing is that we can access the elements of the list.
Yeah.
And maybe we can do this also in the main function and use this add now.
Or maybe just assign something. So we can do list.add the first element, assign some number to it, and yeah, and then we can access it down here and check if this works. I think, oops, right here we are still in recipes. This is called
Array, I think. Heap array.
heap array, okay.
And then we run it.
Yes, and we see this works. We have 12.
Yeah, so
Yeah.
this works. Now we have an array where we can assign elements to it with the add method. We get the elements with the add method, and everything should be fine.
Well, maybe let's try Valgrind.
Yeah, the warning we can ignore. That's just because
We
of the
didn't
add
return
method.
anything here.
Okay, then, yeah, let's have a look on Valgrind, as you said. And you need to specify in the make file this gdwarf -4. Sorry.
Something, I
Yes,
think, yeah.
that's it. One more try.
Compile. No. Okay, but we are leaking memory. So we have 40 bytes in use at exit.
And then leak summary definitely lost 40 bytes in one block.
Okay.
Yeah.
Yeah, this is not good. We need to do something about this. And yeah, I think we already know this. So there exists something like a destructor.
Yeah, now we can use it. It makes a lot of sense to use it now. We said we use a destructor if we have dynamic memory.
How?
You are in the wrong layout now.
Yeah, how do I do it in this layout? Oh, here, okay.
Okay, now we have the destructor here.
Yeah, maybe we can just do it here because it's really short.
And we free the memory, right?
Yeah, we just free the array. So I think everything works now, right?
That's it, right?
Let's run it. Yeah. And we don't have any memory leaks.
Yeah, all blocks were freed. So we used now the destructor and everything is fine, right? Okay, now maybe we implement one more function now in the main.cpp where we just iterate over the array and print all the elements. So you just pass the list as a parameter, then...
Okay.
Yeah, okay, in this case.
No, wait. Yeah, I need
that's okay.
Yeah, we need a getLength method because...
Now, if we want to iterate over the list, we of course need to know the length and implement getLength because length is private. So yeah, getter as usual.
No. Okay, so getLength works. We can iterate over this and
just print them.
So we list at I, then maybe a space, and a new line. And at the end, another new line. Okay.
Yeah, should work, right? It's very boring, I think.
So let's run it. Oh, I didn't call it.
Yeah, you need to call the function, of course.
So let's run it. Okay, for some reason we have some...
you have a double free there. Maybe you can remove the end line, yeah?
Okay, this one I didn't. Okay, but we get an error, okay?
Our program crashed. Has anyone an idea why our program crashed now? We just iterated over the list, printed all the elements with our add method, the getLength. We freed at the end, so everything should be fine. Why is not everything fine?
So it says double free detected.
Has anyone an idea? It can also be wrong. Yeah?
We are accessing some indexes in the array that have been initialized.
I mean, we didn't initialize them, but we did allocate them. So even if there is garbage, this should still work.
Yeah, so it technically is right, but it doesn't bring us to a double free. So
yes.
I think you were first with pointing up.
Maybe we create another list object in the print function, and this scope ends, we freeze already. Then we do it another time.
Yes, this is right. So to repeat, do you want to repeat
Okay,
it?
I repeat it. Yeah, so it was completely right. When we call this print function, this is not a reference here, it's a copy of the list. And then, what I said before, we have the default copy constructor, which just copies all members. So it just copies the length and the pointer. Can you go backwards? So it just copies the length and the array. And when this array pointer is copied, then both objects, the object here in the list function, in the print function, and the object in the main function, have the same address stored in the array. And then, in the very end of the print function, this parameter here gets destructed. So the destructor is called, so this destructor here, and it frees the pointer which was stored in array. And now we have here this second list where this array pointer is exactly the same address. So both lists pointed to the same address. The first list freed this address, and now at the end of the main function, also the second list wants to free the same address, the same array.
Yes.
And then we have the double free.
We could fix this by passing a reference to the print function, but this wouldn't be a very good solution, because then when we first copy it somewhere else, or maybe just by accident, it would again go wrong.
Okay. So maybe I just write the copy constructor, or maybe you can write the copy constructor for me
Do you
today.
want to do the slides first?
No, just
Okay.
first the copy constructor. Yeah? Yeah, could we, but then we couldn't show anything here. So copy constructor, we said const, then the reference, other, and then we can just use an initializer list. And the default copy constructor would now just do assign the length and assigns the address. So it doesn't allocate any new memory or anything like that.
So this is the wrong one. This is what the default copy constructor does. And maybe now you can see more clearly why this goes wrong, because here we are just assigning the pointer from the other array to the pointer we have stored in here.
Yeah. And we also have a picture for that now in the slides. Yeah, what is the problem? Already explained that. That's the visualization. So we have both objects. Object 1 is created first. Object 2 is created then in the print function. Both have the same pointer, so the same arrow here to the same data, to the same array. And if the second object frees the data, then the first object still points to the data and frees it later, but it was already freed, so we have a double free there. And yeah, this concept is called shallow copy, also seichte Kopie, because only the pointer is copied and not the whole data structure behind it.
So more or less just the memory of our data structure.
Okay, now how can we fix that?
So there's a solution, and it's called deep copy, so the opposite of shallow copy. And we fix this by implementing a different copy constructor, which allocates a new array on the heap and then copies over every element from the other list, or more or less all stuff we want to copy from the other data structure. And we also have a visualization for that, and we want our objects after our copy to look like the one on the right, so the deep copy ones.
Okay, maybe you can implement this now in our code.
Yes, so instead of just copying the pointer here, yeah, I'll do it in the CPP file.
So also those constructors and copy constructors can always be implemented in the CPP file, even though we don't do this most often in the practicals because they're just very short.
Yeah, so we already we can just assign the length of the other one because we want them to have the same length. And then, so the copy constructor is of course called on the new object. We want to set the array to a new integer array with the correct length. And then iterate through the other array.
I think you need to use the brackets directly because we're now in the integer array itself.
Yeah, of course. Oops. Like this, and copy over from the array from the other. Yeah. So right here we need to access this private variable from the other object in this class because we don't have a getter for it.
And
Okay.
yeah, we've seen that we can do that. Same as before in the recipe.
Yeah. So, and this should be it, right?
Yeah, then execute our program and give it a try.
Okay, so no error now.
Doesn't crash. Maybe we can run it with Valgrind as well.
And yeah, 0 bytes in use at exit. So now we don't have a memory leak and we also don't have the double free.
So everything is fine now. Any questions regarding the deep copy and the shallow copy?
Yes?
Yeah, so to sum it up, it's like the default constructor only makes shallow copies.
Yes.
So if we have objects that would need a deep copy, we will always have to write them ourselves.
Yeah, I think we have this rule of thumb.
Yeah, we
Yeah.
have one more slide. We maybe
Yeah.
forgot about it, but
So-
that's exactly what you said.
The other options are to either delete the copy constructor, so we don't accidentally copy our object which can't be copied, or implement it. And a rule of thumb, if we have a destructor, so we need to free some memory, we also need to implement or delete the copy constructor.
Okay.
Okay. Then I think,
I think we go to the organizational part first,
and then to the example.
and then we give you a short UML in the remaining minutes. So
Homework one. The submission will be again on the Teach Center, and also it will be available on the Teach Center. I think you can already see it, but you can't access it. So it will be available today at 7 o'clock.
Yes, so after the lecture today.
Yeah. And the deadline will be next Wednesday, so at the 17th. And your task will be to create a UML diagram, like you already seen it in the lecture.
It was already discussed in the lecture, but we hopefully give you a very short glance in 5 minutes.
And just a tip, read section 1 of the description carefully. It starts at 0. Then section 1 is just a list of what your UML diagram has to contain.
Then a few more words on assignment 1. So the deadline was yesterday. I have some statistics about it. So 315 students submitted something that passed the necessary condition. So 315 students can continue with assignment 2. In general, about the grading, you see the test cases, the warnings in the GitLab pipeline. So already have a good idea of how many points you will get out of assignment 1. We need to grade the specifications, of course, but we will do this a bit later, so in May, because we wait until we have signed you all to the tutors and know who continues the course, and then we will grade your assignment. So the specification will be graded at some point in May, so in 3 weeks probably. That's what I need to say about assignment 1, and then something more starts today. In addition to the homework 1, also the team selection starts, and this is also in the Teach Center. And I implemented an if-else that you can only select the team if you passed assignment 1 with enough test cases. Otherwise, there is some error message. If you feel this is not correct, then please write me on Discord and I can have a look on your submission of assignment 1. Deadline is the 16th, so 1 day before homework 1. This is a Tuesday because we have to do some post-processing then. You need to form a team of 3 students, and if you do not have any colleagues yet, there is the option that you register to this special group here. The group for students without team will be assigned to a team after the deadline. So if you register to this group, then I will put you in a team. And I will do this based on your points of assignment 1, so on your test cases of assignment 1, because we would like to have rather balanced teams where all team members perform as similar as possible. Because if you're in a group where you have 2 experts and you're more a beginner, then it's probably hard that you can contribute enough.
What if, for example, we have 2 members, but we don't have the third one?
Yeah, so if you have 2 members and you're missing a third member, you can just register to a team and then you will get a suitable third teammate.
And how random students like being assigned to teams with enough members?
Yeah, I would just go through all the students and...
Based on A1 results?
Yeah, exactly.
Advanced to advanced or?
Advanced to advanced, yeah, because it doesn't make too much sense if there are 2 people having 23 test cases and 1 having 6 test cases, then probably in assignment 2, those 2 will contribute more than the third one. Yeah.
Okay, then, yeah, we just skipped the UML diagram. I wanted to show you something about. This is for your homework, and we just have some tips and an example. Okay, so what is the UML? You already saw this in the lecture. This just shows relations between classes, also the member variables of those classes, if they are public or private, and then also the data types of these member variables. The relations can either be composition, which we already know, which is has a, so just a member variable, or inheritance, which is a relation. So for example, a dog is an animal. You'll learn more about that in today's lecture, and you'll need that for the homework. We have this example here.
So maybe go to the next slide and then we go to the example.
Okay, yeah. So there are 2 tools which you could use. I think in the lecture they already showed diagrams.net or draw.io. This is just some website where you can draw boxes and arrows, which is perfect to create those diagrams. And then we have also Plant UML, which I use to create your reference solution and homework. This is just, you can check out the repository here, but there also exist some online editors where you can create those diagrams online. This is a text-based format, and it looks like this. So you just specify some things. I think it's pretty self-explanatory, and you can look through that on yourself.
So if you don't want to draw lines and the boxes yourself, then you use probably Plant UML, and if you want to draw more, then you'd use diagrams.net.
Yeah.
Okay, and this brings us now to the example.
Mm-hmm.
And we will draw it now by hand. And
so I hope this works.
Yeah, we have to go to the iPad, and you just tell me what I should do. Okay?
Yeah. Yes. So I created this description, which is similar to the one you have in your homework, and I marked all the classes with this font and this symbol, which is for class. So we have this UML diagram describes a dog. So first, let's just create a class called dog. Maybe if you can draw that. Yeah. And then we have a dog is an animal. So we'll create a second class animal, and the dog has an arrow to this animal because this dog is an animal. You'll learn more about that in today's lecture, but we just have to do this now. And then we also see all animals have a private name and a public method eat. And we'll write this in the animal class. And additionally, the dog has a private field fur color, 4 legs, and a public method which allows the dog to bark. So, yeah. And you also forgot to write the data types in the classes. Yeah. In your homework, it is mandatory to specify the data types of all the member variables you use. You can do this just by writing a colon after each member variable and then specifying what type it is. But don't worry, everything is explained in the assignment descriptions, I hope. And if you still have some questions, you can always ask on the Discord. So, and then we have,
Yeah, where should I continue now?
You can.
What else should I do? So we have now the list of legs. Okay, what is the next thing?
Yeah, okay. So then we have also the class leg, because leg is also marked with the symbol and the special color. And a leg just has a private field for its length and a public method that implements walking. So we'll create the private length and the public method for walking.
And how is the dog now related to the leg?
Yeah, and so the dog has many legs, or has exactly 4 legs. Yeah, and this is indicated by this diamond symbol.
And also here I hope this is now visible enough, I just write it again. In this case, we just have a list of legs. So we have not the data type leg here, but we have really list of leg or array of leg, whatever you want to use.
Yeah, you should also specify it like that in your homework, so we know you understand the description.
I'm sorry, what data type should we use for legs and walking?
Yeah, so for leg, we already have to have the class leg, so you can just use that. And for
Do we have to like write it down in the dog that it has a separate class, or?
what do you mean?
Well, I mean, for example, there in name we write string. Do we have to write under the legs that it is another class?
No, we have list leg there with legs. So we specify that these legs are a list of legs, and we know what a leg is because we have drawn it there, and we also have this error.
Yeah, so you either have primitive types like an integer or a string, or you have types that you created on your own, which is the leg, which is the dog, which is the animal.
Yeah.
And of course, we use some more things like a list, because we have a list of legs here, not just a single leg. And nevertheless, we indicate that the dog has legs with the symbol here. Yeah, and these are the components.
And like we didn't model the color for the dog, so we just wrote color there. This is also fine in the homework if the type which is mentioned is not written like in this color and with the symbol, you can just come up with any type or just use string. It's just important that we see for those that are lists, for example, that we know that you know that is a list. If this made sense, yeah.
Yeah.
So it doesn't matter if you write list or STD vector or anything.
Yes, this is also mentioned in the
Question like parameters and methods, how do we specify them? Do we use the name, the column, the type, or just the type?
normally we always write the type after the variable with a colon, but we don't have any parameters in the UML diagram. So it's pretty simple, the homework. It's not that many classes.
So it's just important that you write for all member variables the data type. For the function, it's not important.
Yeah.
And do we have to write something for the methods? Do we have to write something for the methods?
No, for the method, it's just enough to write the name of it.
Yes.
Wouldn't we need a class color in this example when we use for color?
Yeah. Yes, normally you would create a class color, but because I didn't want the homework to be that big, I just marked the most important classes with the symbol, and the ones which are not marked like that, you can just use like data types.
So I think in the homework, for example, there's an address.
Yeah.
And for an address, you can use a string, for example, or you can also write address, but you don't need to specify the class or the data type itself.
Yes.
We don't need constructors in the UML diagram. It's just the methods and the variables that are mentioned in the description that need to be modeled.
What about deleted constructors or deleted anything else?
No, just the methods which are really mentioned in the...
Yeah? No, you don't need to follow any coding standard in the UML diagram, except for marking the relations and marking private and public, but you don't need to use some prefix there or postfix for variable names. You don't need to write an underscore, for example.
Yes, so it's not that strict. And for the planned UML example I had down there, it would look like this if you do it with planned UML. Yes?
Can we use any software to draw diagrams?
Yes.
I mean, I can use something that generates this planned UML approach instead of just like dragging.
Yeah.
So it really doesn't matter what tool you're using. It probably is best practice and also most easiest thing for us that you don't draw it by hand.
Yeah.
But use any tool that is available and that you like the most. We just gave you some tools there that you have a reference if you don't know what to do.
Yeah. So you're completely free how you draw it. Yes?
We have to upload a PDF or DMP or what?
A PDF
PDF.
file is the submission, yes.
Okay.
So if there are no further questions, then I would say we start in 10 minutes with the lecture, David? Okay, so in 10 minutes, 5:30, the lecture starts.
Yeah. The homework will be more clear if you read the task description. Most of your questions will be answered.
Thank you.